Well, I think those 3 talks, the first 2 really encouraged us to quit our day jobs and start working on ways to either cut down on water or to actually use more water. And then that 3rd talk encouraged us all to swim across the Danube. So I think we do have some time for some questions. So why don't we get our panelists up here to this nice panelist table. And I'm gonna actually just go to the audience because you guys haven't had a lot of a chance to really get your voices heard today. So who has a burning question about food and water from these last 3 talks? Anyone?
So I have a question about seawater greenhouses. Why isn't the Sahara already covered? What's the barrier to, what's slowing your rate of adoption?
I blame the Romans. When the Roman Empire, before it collapsed actually, they moved into North Africa because there wasn't enough food grown in Italy to keep the empire going. And at that time it was much more vegetated. It was known as the breadbasket of Italy. And it's a very delicate thing that a combination of over-abstraction, over-grazing, flipped the region from being relatively, I mean, it's always been hot and sunny, but it quite rapidly flipped it from being productive to being unproductive. And I think we're seeing that same pattern playing out now in California, perhaps. It's a delicate thing. If you over-abstract and you take away more than, if you're extracting stuff at a faster rate than it's being replenished, then you create desertification. Does that?
I kind of explained myself clearly, sorry. I loved your story about using these seawater-powered greenhouses in order to revegetate. So, but I remember hearing you talking on the radio about it when you were with a pilot project in the Canaries some years ago, and I just kind of wonder why it's not everywhere. Why hasn't it already happened that such a beautiful technology isn't progressing more rapidly? What's the barrier to your growth?
There's 2. There's 3 actually. First of all, it's a very counterintuitive idea. People don't really understand it because what you do understand is you don't use seawater in agriculture. You know, you don't put salt on crops. There are dangers of using seawater, and so people don't understand the process very well. Secondly, as we just have pointed out, people expect water to be free. If there's a cost to it, then who bears that cost? In countries like the Middle East, for example, while Saudi Arabia is probably the cheapest water in the world. I think it's something like 3 cents a cubic metre. I pay £3 a cubic metre in London for water. So there's no incentive for a farmer to invest in a technology that produces water when the government give it to him. So it's a political issue, and it's a commercial issue. There's no food grown anywhere that isn't grown without some subsidy or intervention of some sort. It's you know, we're in a kind of global race to meet these conditions. And in fact, there are for farmers in Africa, there's a very onerous set of conditions that have been created by the European Commission through the Common Agricultural Policy, which penalises crops coming from Africa, as does imports into the United States. So it's tricky.
Okay, another question?
Just a quick question about probably the water resources within the United Kingdom, and this hasn't been mentioned, but we have a great network of canals that could be used to redistribute water, because of course we have shortages here. So, and this is for my own education, but I mean, who owns those canals? Can they be used? Is there a way of monetizing it? Do you think the future is probably addressed to Paul, I think, but any of you can answer.
I wouldn't be 100% qualified to comment on that, but what I can say is that water lends itself to a natural monopoly. that even though the UK water sector is privatised, it's probably one of the few examples where it's completely privatised, you still don't, you get relatively little transfer of water across the catchments. It can happen, but that's one reason it tends to be managed, and it's a natural monopoly. There are also, you can do it using pipe distribution. There are good examples in Spain where one region will supply water to another utility, but they typically use conventional means, as conventional pipes as opposed to a canal.
I can just add one nice story. There's an engineering company called AECOM who have come up with an idea called the natural grid, which is to join the canals and to create new canals with Scotland down to the south of England, exactly for what you suggest, for transferring water, but at the same time for using it for distributing power. So running high voltage DC cables in a purpose-built grid that also at the same time puts residential values up for property development alongside the canal itself. It's a very nice, elegant, joined up bit of thinking, which probably won't happen.
Do we have another question?
Just curious about smart metering. You see, a lot of technology is being put now into smart grids and smart metering for mostly energy, but a lot of thinking is going now into sort of, let's connect together just all energy meters and water meters, which is the hardest actually, because those meters do not have power source, first of all, but people still want to do that. Do you think there is any reason to do that at all? Any benefit?
There is a big move towards smart metering, automatic meter reading, automated metering infrastructure. It can enable many things, including leak detection, better optimization. There is talk about why we don't integrate energy and water. They tend to be separate utilities. I'm not sure that there's a clear, obvious advantage in putting the two metering systems together, but what I have seen is there is areas where you can get the water infrastructure network to speak with the energy network so that you can play with peak and off-peak electricity rates. So you can say, oh, I'll fill the reservoir when I have an abundance of electricity. So the water network can act as a battery to move water when you have excess power or release it when you don't. So that's a little bit separate to the meters, but it is a way of integrating both networks.
We haven't seen anything like that. What we do see is more integration of data input coming from use of sensors to detect different things in water, quality of water. There's also a move from utility side, this is more in the US, about finding new models, revenue models to make money, because utilities basically make money by one thing, and they're looking at different ways, similar to what energy companies are doing.
There's one good example worth looking at, a company in the US called Fathom. They've got a really clever business model. They've based it on the Apple App Store idea. So they get all of the water meters, a bit like the way Apple went to all of the music publishing companies and persuaded them to give them their music and put it through iTunes. So they persuaded all the big metering companies, say, let us take your data, and we will then provide this data to data processing solutions which can optimize water transportation. And we can give you a revenue cost share back. So it's using the data and allowing the meters people to share in the downstream value of using the data. And it gets into all these issues of who owns the data and who benefits from it. But it was one of the more clever things I saw.
I think we have time for one more if we have a burning question.
This may be a ridiculous question, but I'm going to ask it anyway. I think I was watching the television a while back and I was hearing that a huge percentage of the world's fresh water is in the poles, the North Pole and the South Pole and the ice there. I mean, the disadvantage, of course, is that global warming is slowly melting that. But actually, the advantage is that it's actually releasing the water for us in a process, presumably, that otherwise would take a huge amount of energy to do that. Can't we harness that in some way?
I think one of the challenges is it'll probably end up in the ocean.
But one of the reasons is maybe we can stop it going into the ocean and raising the water by doing something else with it.
What, do you harness it to do what? Do you mean to catch it, to trap it, or to use it?
Yeah, I mean, they put oil in pipelines across Siberia into Europe. Why can't we do?
You couldn't justify it on the cost basis. It's just a commodity which currently doesn't lend itself to being transported along those distances. Just now, if water became much more expensive, you probably could, but at that point you'd probably look to desalinate from the ocean. That might even be cheaper again. Because actually it's funny, but transporting water is very energy intensive. In Northern California, they pump water from Northern California to Southern California over the Sierra Nevadas. Turns out the energy footprint of doing that is exactly equal as if they had desalinated water in San Diego. But people often say, oh, desalination is energy intensive, we'll bring it down. So you'd run into that challenge too, I think.
Desalination is no longer energy intensive, actually. It's in comparison with shifting water, I think the best figures now are in the region of sort of 30 to 50 pence to produce a cubic metre of water. And as I say, I pay £3 for a cubic metre of water in London, but which includes the delivery. So in fact, making it at source is a very viable solution.
All right, let's thank our panelists for their amazing talks.